Good afternoon. Hello, Isaac.
So, are we going through all of the 2012 questions or all three of them?
I'm just covering questions 3 and 4 because question 4 is a really awesome question. And question 3, we haven't talked about that concept in a while.
Okay.
And then after that, if you have any questions from the Master Math Mentor ones, I can answer any of those if we have time, which we probably will. Those 2 questions shouldn't take that long. Well, I assume everyone saw that graduation has officially been moved to July 9th. No, 6th, July 6th at 9 a.m.
Yep.
Not surprising, though.
Why 2 days after Independence Day?
Oh, I don't know. Really, they just picked 6 days in mid-July with 2 graduations each of those days. And Langham since we already were going to be the first graduation, is still going to be the first graduation. So that's the next time I'll see y'all, I guess. Okay, well, it's 1:05, so we'll get started. We'll let other people in as they arrive. A lot less people than usual. Okay, so first, I want to talk about the exam this year. No, not that. Let's go here. Now, this is the same slide that I've usually been showing, but y'all should have gotten probably several emails recently about the exam. I don't know if y'all got this PDF, but I did post this PDF like 30 minutes ago-ish to the Google Classroom, 2020 AP Testing Guide. It has a lot of information about how this year's AP exams will be. A few things that will be important is that on Monday, May 4th, you will get an email with your AP ID in that email and telling you all the exams that you're taking and when you're taking and when those will be, as well as on Monday, May 4th, you will then have access to the testing demo where it will show you how the like the system will work, doing the problems and uploading them, and you will even get have access. You'll even be able to have access the demo, and you'll be able to actually see and use the system ahead of time, so you know how to upload stuff on the day of the exam. This PDF, which you should look at if you're taking the exam, talks about the AP exam e-ticket and stuff you need to know about that, stuff you should do day of the exam. First thing about the e-ticket, for each exam you take, you'll receive an e-ticket in your email 2 days before the exam. It'll have your Apple ID and so specific e-ticket information for that specific exam. And if for some reason you're not able to take it on the 12th and you don't take it, they will then assume that you're taking it on the makeup day, June 1st, and then 2 days before then you would get an e-ticket for that makeup exam. This file again has the whole calendar of when they are. Again, ours is at 1 p.m. So at least you're already used to doing calculus at 1 p.m. One thing to keep in mind, some people think that the curve that they use is comparing people. You're not competing against anybody else from this year. That is not how they do their curve. How they figure out the cutoff for 3, 4, and 5 is essentially comparing it to previous years. That way, this year's exams are no different than any other year's exams, where what it means and the knowledge needed to earn a 3 one year, like in 2017, is the same knowledge needed to earn a 3 in 2020, and what's needed to earn a 5 in 1 year, same as what's needed to earn a 5 in another year. That's how they break that up. So it's not going to be any more difficult to earn a 3, 4, or 5 this year. They're planning on making that the same as normal. What else should I highlight before going on? You can copy and paste during the exam, like from some word processor. It'll even have the capability of, like, you have two screens side by side to see the question on one window and where you're working the problems on another. Or you could just completely work it somewhere else and then just save and attach that, save that file and then attach it. You could do everything handwritten, which would probably be the easiest. I think the easiest way to do it would be to just handwrite on your own pieces of notebook paper. And you're allowed 5 pieces of paper, like uploads, per question, and there's 2 questions. So just like say the question number, your Apple ID, your name, and page number, and you take a picture, turn it into a JPEG or PDF, then upload it. I think that would probably be the easiest way, but this goes into detail about the different ways that you can submit your work. I'll quickly talk about one other thing. Page 35. Okay. If you watch I'm pretty sure that you were sent a video, and I also uploaded that video. I didn't know y'all were sent that. But for any exams that have 2 questions, which ours does, you need to start your check-in process 30 minutes before, so 12:30. You'll use that e-ticket and fill in any identification information. Then I had consistently been saying you have 25 minutes, then 5 minutes, then a 5-minute upload time, then 15 minutes, then a 5-minute upload time. In the screen when you're doing it, it will have a countdown timer for 30 minutes for the first question, and then for 20 minutes for the second question. If you fully understand and like have mastered how you're going to upload your work and you have great internet, like you essentially may not need the whole 5-minute upload time. But that's what that time is meant for. I would not wait till the 29th minute. Obviously you can't wait till the 30th minute because then it's past due. I mean, maybe the 26th or 7th minute, that's when you might want to upload. But when the timer is going down, when it hits 5 minutes, it's then going to flash red and tell you that you need to start submitting your response. And about that time, be wrapping it up and preparing, and maybe that's when you start taking your pictures and go through the process of however you're going to upload and submit your response. But it'll say it's a 30-minute timer, and then like start flashing red at you starting at the 5-minute mark, and similarly with 15 and 5. Okay, I just wanted to mention some of that stuff, but this file is on the Google Classroom for you. Oh, and one other thing. Let's go to the calendar. Okay, so on the calendar, that was last week. In the 2 previous weeks of assignments, I was really for our grades, I was really just looking to see if you did. Just this is wrong one. I was really just looking to see if you did most of the assignment. So just looking for your work of if you did most of the assignment, then I gave you 100 for that. Although that did mean you have to turn something in. There's a small few people that haven't turned anything in. But for this week and next week, I want to be a little more specific. I am still going to be providing keys, so it's not going to be crazy hard to still get 100. Actually, it shouldn't be hard to still get 100 this week and next week anyways. But I'm going to be more specific in what I look for. As well as that then allows that, I mean, if you're just running low on time, less things will matter for this week's grade and next week's grade. So this week, we have the 2012 FRQs and the Master Math Mentor FRQs. What's going to go into this week's grade is just the Master Math Mentor FRQ number 3 and number 4. And so if you're taking the AP exam, which is, I think everybody but Sean is taking it, you should do all of the work from this week. But the only part that's going to go into this week's grade is Master Math Mentor FRQs numbers 3 and 4. I think it's like C3 and C4. So it's just, I'm going over the 2012 ones today because these are the 2 problems that I'm choosing to do today are like very good problems that I need to remind you how to feel like we should go over. Haven't done some of the stuff, in a while, as well as want to give you time to work on the Master Math Mentor ones before I just go over how to do it. And then next week, I'll provide several stuff in the assignment for tons of practice, but the only part that will be in next week's grade is the one that will be called Passwater BC Mock, the one that actually says Mock AP exam. In the week of the 11th, the only thing you'll have then is just one short circuit. And then there's no point in doing anything afterwards. So the only grade the week of the 18th will be some Google form questions that I ask you. That will be like, hey, how'd the AP exam go? Where are you going next year? Just questions like that. And then the last week of school is, well, no school. Okay. Well, let's do some problems. So again, I'm going over numbers 3 and 4 from the 2012 FRQs today. If you're curious about number 5, you could check the AB video from this morning. I went over number 5 with AB, and that was one of the questions that was the same that year. Okay. 2012, number 3, BC. Actually, let's move that all the way over there. Okay. So we got this graph. It's a graph of F, and we're told that G is the accumulation area function integral from 1 to x of f of t dt. We're asked to find the values of g of 2 and g of negative 2. Well, g of 2 would mean the integral from 1 to 2 of f of t dt. So we just need to find the integral from 1 to 2. So that was just going to be the area of this triangle. And if this is all the way, we're told that this is a straight line, and that just goes down to -1. So then this one, that point right there must be the point 2, -1/2. So that's 1 times a half divided by 2, which is what?
-1/4.
Yeah, it'll be -1/4, because negative just because it's in the denominator below the y-axis, below the x-axis. -1/4. Okay, then g of -2 will mean integral from 1 to -2 of f. Okay. I'm gonna slightly turn that around and put a negative in front and then say integral from -2 to 1. Integral from -2 to 1. Well, integral from -2 to 1 of f, we can break that up. We got this semicircle, and we got this triangle. Well, that's 1 times 3 divided by 2, which would just be 3/2. Then what is the area of that triangle going to be? I am going to move that up there. I didn't put it there. Ooh, over there will work. So the area of that triangle, so that's 3/2. The area of the circle, that'd be pi times 1 squared, would be the area of the whole circle, which would just be pi, but then divided by 2. So again, we got that negative 3/2 is the triangle, but then that part that's below is below the x-axis, so it'd be a minus pi over 2. And when you could leave your answer like that, or you could distribute the negative, either way. So that's part A, which was 2 points that year. And then part B, oh, I can completely hide that? Well, that's way easier. I should have been doing that all along. Okay, so G prime of -3 is what we want. Well, we would need to figure out what G prime of X is. G prime of X will equal what?
F of X.
F of X. Meaning G prime of -3 is F of -3. And F of -3, well, let's go back up there. F of -3, 1, 2, 3. Must be 2. F of -3 is 2. Okay, then G double prime of X would then be F prime of X. So G double prime of -3 would equal F double, not double, F prime of -3. So it's just the slope of that region. So the slope of F at -3. Yeah. Okay, well, right here it is going, the slope of this line is going up 2, and it's going over 2. So it does have a slope of 1. And there we go. So that's parts 3A and 3B. Part B was also 2 points. Okay, now part C, we're asked to find the x-coordinate of each point at which the graph of G has a horizontal tangent line. But the graph of G has a horizontal tangent line. Well, horizontal tangent line will occur when its derivative is 0, meaning when G prime of X equals 0. Well, G prime of X, as already stated, is F of X. So we're looking for when F of X is 0. And that's where we will have a horizontal tangent. Well, that occurs at X equals -1 and X equals +1. So for each of those, we're determining whether G has a relative min or relative max or neither at that point. So part C, horizontal tangent at X equals 1 and -1. At X equals -1, G of X okay, will that be a relative min or a relative max at -1?
Max.
Yeah, that'd be a relative mass because a G prime is going from positive to negative. That's a relative max since G prime of X switches from positive to negative. And the other one at X equals positive 1, G of X has a relative minimum since G prime of X switches from negative to positive. So that was part C, and that was worth 2 points.
On the second part here, isn't at x equals 1, it's still in the negative region of f of x, which is still g prime, right? So it doesn't have any critical points.
Oh yeah, I was thinking about a different problem. Was not even, yeah, you're right. So at X equals 1, G of X has neither min nor max since it stays negative. Okay, then part D, we're to find all values of X for which the graph of G has a point of inflection, and explain our reasoning there. Well, a point of inflection occurs when we change concavity, meaning it would occur when F double prime changes from positive to negative or negative to positive. I mean, well, here G. So we're looking to see if we want to see if G double prime of X changes sign. Where does G double prime change sign? Well, G double prime is F prime of X, is F prime, meaning the slopes, So where does F prime change sign? And that is where we will have a point of inflection. So there are 2 of those spots there. Where would it be our 2 points of inflection?
It changes the sign of the slopes at -2, 0, and 1.
Yeah, at all 3 spots. So G of X has point of inflection at X equals -1. No, that's -2, right? Yeah, -2. At -2, 0. And
And I have just a quick question over just that part in terms of, in this type of question, did we not need to worry about those x values being differentiable on the graph of f, since those are just line segments at sharp turns? But since we're just identifying them and not having to graph it, we don't omit any of them.
Well, for it to be a point of inflection is just defined as a point where the function changes concavity. And so, no, it doesn't have to be differentiable at the point where it changes concavity. If it's concave up before then and concave after that point, then it does. Then it is a point of inflection as long as the point does exist.
Right. But in this case, like with the graph of f being shown, like would f prime of -2 not exist because that's a sharp turn?
Oh, well, f prime of -2 may not exist. F of -2 does.
Oh, okay.
And that's the key thing. It's the point that we're talking about. Because we're saying that when x is -2, 0, or 1, g has a point of inflection. Well, g of all three of those points would exist. And we see from the picture, from the graph, that g prime would also exist there. So the only thing that doesn't exist there is f double prime, but that's not a big deal.
Okay, gotcha. Because we're looking at g, not f, right?
Yeah. And so the original point where the point of inflection would be does exist. So I just need to provide our reasoning. And so our reason, I mean, it's kind of this, what we wrote to begin with, of what we were looking for, that we have a point of inflection at these 3 points since, since g double prime, which is f prime, changes sign at those points. Okay. Next, problem 4. 2012 problem 4 is a really awesome BC question, because all 4 parts are asking us to approximate a certain function value, but in 4 different ways. 2 of those ways are kind of A-B level, and then the other 2, parts C and D, are BC only level. So part A asks us to write an equation of a tangent line to the graph of f at x equals 1, and use that to approximate f of 1.4. So tangent line approximation is part A. Well, to do that, we need to know what is, we're writing the tangent line to the graph of f at x equals 1. We need to know what is f of 1. And then we will also need to know what is f prime of 1. So f of 1, they told us, is 15. F prime of 1 is in the graph, and that's 8. I mean, is in the table, and that's 8. So 15 there, 8 there. Now we can make the equation. I'm going to go ahead and have f of 1 moved over to the other side. So we have y equals 15 plus 8 times x minus 1. So that's the tangent line. And now let's do our approximation. Y equals 15 plus 8 times 1.4 minus 1. Okay, well, that is just 0.4. 0.4 times 8. Well, 4 times 8 is 32. And deal with the decimal, so then that's 3.2. 15 plus 3.2, that's then going to be 18.2. So that's the linear approximation. Learned how to do that back in like October. Part B is a midpoint Riemann sum with two subintervals. And so it's an approximation because Riemann sums are just an approximation. It's not in the actual integral. So midpoint Riemann sum with two subintervals of equal length. Get the values from the table to approximate the integral from 1 to 1.4 of f prime. So from 1, and so we'll do that first, then discuss how that actually gives us an approximation of f of 1.4. So we're going from 1 to 1.4, and we want two equal intervals, two subintervals of equal length, meaning our first rectangle is going from 1, oh, I got that right. That was weird. What is, we're going from 1 to 1.2, and from 1.2 to 1.4. So we are approximating the integral from 1 to 1.4 of f prime of x dx by using a midpoint Riemann sum. And so for the first rectangle, the width of that first rectangle is 0.2. What is the height of that first rectangle going to be?
10.
Yeah, it's 10. So it's 10 because we need to use the function value of the midpoint of the interval. So that is 10. So that's the area of the first rectangle. Then now the area of the second rectangle. The width of the second rectangle is also 0.2. And the height of the second rectangle is 13. Okay, 0.2 times 10 plus 0.2 times 13. Well, I'm gonna do something real quick. 0.2 is 1/5, right? Just if I distribute that 1/5 out, then I then have 10 plus 13, which is 23. Okay. So 23 over 5 is my approximation for that integral. Well, we are then told, so we did that part of the problem. That was that first sentence. We then said use that approximation of the integral from 1 to 1.4 of f prime of x dx to estimate the value of f of 1.4. Well, how could that work? Well, if we are taking the integral from 1 to 1.4 of f prime of x, if we were to actually integrate this, the integral of f prime is f. So we'd have the function, and then we'd plug in our upper and lower endpoints. This integral would end up being f of 1.4 minus f of 1, based on the fundamental theorem of calculus. So by fundamental theorem of calculus, we get this idea, and we want to be able to estimate the value of f of 1.4. So we need to get f of 1.4 by itself. We'll just move this over the other side, f of 1, move that to the other side. So f of 1.4 will equal f of 1 plus the integral from 1 to 1.4 of f prime. Well, f of 1 they told us was 15. Plus, we just got here that the integral from 1 to 1.4 of f prime is approximately 23 over 5. So then I'll have 23 over 5. Then we can add those together. Or what is 23 divided by 5?
I think it was 4.6 or something.
Yes, yeah, it would be 4.6. So then this is 19.6. The cool thing about this problem is we're approximating the same function value, over and over and over again, and it's actually going to get more accurate each time. So the tangent line approximation was 18.2. The Riemann sum approximation for f of 1.4 was 19.6. And then part C will use Euler method, and part D will use a Taylor polynomial, and it will get more accurate each time. So let's go to part C and D. So in part C, we're using an Euler method. We're told 2 steps of equal size. So our change in x would be 0.2. It's going to be 2 steps of equal size because we're going from 1 to 1.4. So just that difference. So the change in x each time will be that. Let's see, well, let's make our usual table. We'll have x, we'll got y, dy, dx, and dy. Probably don't need it that long. Okay, well, we're starting off with f of 1 equaling 15. So 1, 15. And so what will be the derivative at that point? Well, we get that from the table is 8. So then what's going to be our dy that time?
$1.6.
Yeah, 1.6. Because again, the dy we've defined previously as it's dy dx times delta x. So if we take 8 multiplied by 0.2, we get 1.6. Okay, the next step in our Euler method, we'll just add 0.2. So we'll have 1.2. And that next y value is going to be what?
16.6.
Yeah, 16.6. And now we need the derivative at that point. Well, the derivative at 1.2 from the table is 12. And so now to get the dy dx, we'll take 12 multiplied by 0.2. 12 times 0.2 is what?
2.4.
Yeah, 2.4. I guess it's not more. Yeah, we'll see. And then for the last one, 1.4. We'll now add the previous y, that change in y to there. So 16.6 plus 2.4 is exactly 19. And so we can give I'll just write that as a final answer that f of 1.4 is approximately 19. There we go. And now part D. Part D, we're asked to write a second degree Taylor polynomial for f about x equals 1. And we'll use that Taylor polynomial to approximate f of 1.4. So let's first write down the formula for a Taylor polynomial, a second degree Taylor polynomial centered at x equals 1. So that means I'm going to put p sub 2 of x will equal, well, first f of 1 plus f prime of 1 times x minus 1 plus f double prime of 1 over 2 times x minus 1 squared. Okay, so that's going to be the formula for a second degree Taylor polynomial centered at 1. And so we need to fill some stuff in. P sub 2 of x. F of 1 is 15. Plus f prime of 1 is 8. Times x minus 1. plus f double prime of 1 divided by 2. Well, f double prime of 1 is 20. And then 20 divided by 2, that's going to be 10 right there. Is x minus 1 squared. Okay, so that is our second degree Taylor polynomial centered at 1 for this function. Now we just need the approximation. So we're going to plug in 1.4 in for x. So p sub 2 of 1.4 is 15 plus 8 times 1.4 minus 1 plus 10 times 1.4 minus 1 squared. Okay, well then this is 15 plus 0.4 times 8 is 3.2. And we saw that much in the tangent line approximation, which should make sense because a tangent line approximation is just a first degree Taylor polynomial. Okay, then this will then be 0.4. 0.4 squared is 0.16 times 10 will then be 1.6. Right, 0.4 squared, 0.16 times 10, 1.6, yeah. Okay, so then that's 18.2 plus 1.6. 19.8, right? Yeah. And there we go. So that was questions 3 and 4 from the 2012 FRQs. I did question 5 with a B earlier, and then now, if you have any questions from the Master Math Mentor FRQs, we have some time. I could answer those.
Question 3, part D.
Question 3, part D. Let's go find that. Oh, I don't want to just show the answers. This way. I did not open that file. Get that real quick. Question 3, part D. Okay, so well, all of question 3, we're dealing with a bunch of stuff with area, volume, arc length, all of those kind of things from Unit 8. Part D asks us to write a simplified expression for the perimeter of region R for between 0.5 and 1, but we don't have to calculate. Okay. Well, let me go here real quick so I can write on that. So they have 1 written right there. 0.5, I guess, will be somewhere in the middle. So we want an expression that would represent the perimeter of that. It would represent the perimeter of that region. Well, the bottom side of this region would be how long?
1/2.
Yeah, it'd just be 1/2. So this bottom side is 1/2. So we'll have 1/2 plus the length of this purple line plus the length of the blue curve. How could we figure out the length of the purple line? Well, the length of the purple line that I drew, the length of that purple line would just be equal to the y value of the function at that spot. It would just be equal to the y value of the function. So we're dealing with the function -2 ln of x. And so this point right here is f of 1/2. meaning that point right there is -2 natural log of 1/2, which is just a point. And so that's the length of that purple vertical line, and the length of the purple horizontal line is just 1/2. And we could be even more specific with this if we wanted to. They did say simplify. If we have a number in front of natural log, what could we do with it?
Raise the inside to the power.
That we could raise the inside to that power. Meaning we would raise that 1/2 to the -2 power. So it would get both squared and flipped, which would mean natural log of 4. Okay, so that purple vertical line has a length of natural log of 4. The purple horizontal line has a length of 1/2. And we now just need the length of the blue curve. Well, to get the length of the blue curve, we'll use the arc length formula. Arc length formula is integral from A to B, the square root of 1 plus f prime of x squared. That's the formula for arc length. And so we'll use that for the blue curve, which will end up being the integral from 0.5 to 1 of the square root of 1 plus. Okay, well, what is the derivative of f? Let's write that down up here. What is f prime of x?
-2 over x.
Yeah, -2 over x. So that'd be -2 over x. But we need to square it on the inside, so we'll have a positive 4 over x squared. 4 over x squared there, and then dx there. So then this integral here, integral from I should say 0.5 down there. Integral from 0.5 to 1, the square root of 1 plus 4 over x squared dx. That integral represents the length of the curve. Natural log of 4 is the vertical part, 1/2 is the horizontal part. Just all three added together would be an expression for the perimeter. Does that clarify things? That's pretty much the whole
Yeah.
thing. You just need to write out all three of those things added together. You don't have to actually evaluate the integral.
Yeah, my main thing was looking at that with when the -2 natural log of 1/2, because on theirs they only simplified it as far as 2 natural log of 2. So how far is simplified enough for the phrasing of the question where it's simplified expression, or could we have just left it and been fine as well?
So I would take, let's see, what did they write as their answer? So D. Okay, so while they simplified it like this, AP exam would take either one of these things. Notice how he separated his point values. He separated as 1 point for the straight line distance, which is the 1/2 and the 2L and 2, and then 1 point for the curved distance, which is the integral. Well, this integral here is the same thing as this integral here, even though we actually evaluated the squared part here, and it's not evaluated over here. -2 natural log of 1/2, same thing as 2 natural log of 2, which is then also the same thing as natural log of 4. All of those are the same. The right side of this equals is not more right than the left. So if you left it as -2 natural log of 1/2, AP exam would have counted that.
Okay, so it's not so much.
What does the simplified part mean?
Oh, the simplified means they don't want anything in function notation still in your answer. So at -2 natural log of 1/2, that shouldn't say f of 1/2. Or inside your integral, that shouldn't say f prime of x. There shouldn't be any function notation in your integral.
Okay.
Or at the very least, if the person who made this FRQ meant for it to only be the right side, AP would not do that. College Board would still take the left side of this equal sign.
Okay. So it's kind of like the
On a free response
rules.
question, College Board does not absolutely require simplifying as far as possible. So even the left side of this would still be okay for College Board, as long as you don't have function notation still.
Right. So it's like our other ones where as long as it can be plugged into a calculator, sort of
Yeah.
that sort of logic.
Yeah. Any other questions on any of the Master Math Mentor ones in that file?
I also had a question just over the reasoning of question 4, part D, and just the logic that we would take, because it's just asking more of a logic question.
Question 4, part what?
D.
Question 4, part D. Okay, so in question 4, all throughout, you're using the difference of the equation dy dx equals y squared minus y, which you could factor y out of that, and you get dy. Oh, how'd that right? I don't know. Dy dx equals, if we factor y out, we get y times y minus 1. And we are asked if that is, this part D is essentially just asking if that is a logistic growth example. And if we're using y with logistic growth, our logistic growth formula said, if I used y instead of the usual p, it would be dy dx equals ky times m minus y. So that's what a logistic growth formula would look like if we had it be like dy dx, where k is some constant and m represents the carrying capacity. Now that's the logistic growth formula for the differential equation. So could the one they gave us end up looking like this, where we have some constant times y times a constant minus y?
No.
No, it can't. I mean, unless they did something weird. Let me go check what they did. I'm pretty sure it can't. Oh, you said it was question 4. Yeah, I can't. k is meant to always be a positive logistic growth, we know should look something like that, where this is the carrying capacity. So it's going up forever. It's going up forever. The derivative should be positive. So k is going to be positive. The only way to change this so that we have a number minus y, we'd have to pull a negative out in front out of that, and then k wouldn't be positive. So because this is the logistic growth formula, and this is the equation we do have, the answer would be no. Like those just don't equal each other. Because a logistic growth model should have this k value should be positive. You'd have some positive constant times y times the carrying capacity minus y. And there's no way to manipulate the given differential equation to look like that, which is pretty much what they said, right? Yeah, it's exactly what they said. Well, not exactly. I mean, they picked a number for what c could be. If c was 1, then we have the derivative is 1 minus y, but then those are just not equal. Those are not the same thing. Because even the differential equation we're dealing with is y times y minus 1. And so that k value is definitely, the k value is just 1. Well, really, it would be -1, which would not be logistic. So it's really, the purpose of that question is just to know and compare it to the logistic growth formula. Any other questions? Although it's after 2 now. Don't know where that came from. Okay, well, like usual, the video will be posted later. Friday, I will answer any more questions you have from the FRQs. And the, like last Friday, I thought it'd be cool to do another Kahoot this Friday. So we'll do a practice Kahoot during Zoom on Friday. I have had some people really concerned about getting the work done on time or the amount of work they're doing, because things are a grade, and you probably saw how the grades will be done this semester, which will considerably help some of you. And some of you, I helped your 3rd grading period out, and now you're about to get helped out even more. Like, you should be doing some work to prove that you're working on calculus, but I mean, if something's going on that you just can't get the work done in time, talk to me. Like, this life is not normal right now. This is not normal. There is grace, as I said in that message yesterday. Don't feel like you have to get everything done, or definitely don't feel guilty if you can't. Any last comments or questions before we end? Okay, well, have a good day, everyone.
Bye.
Bye.
Bye.